So I'm going to go through the fast way, the non-drawing way to finish. This is problem 3 on the bottom of your notes paper. So the fast way to do Riemann sum is just to make a table. If you don't have a table, you know the shortcut that you don't have to draw the whole picture in. So I made a table for n equals 3 values. So our rectangles are all width 1. And so you need the start of the interval, and then you go by ones until you get to the end of the interval. One thing you're going to notice is that there are 4 values, but there's only going to be 3 rectangles, because for left Riemann sum, we're going to use the left 3. For the right Riemann sum, we're going to use the right 3. So for left, we know all of the widths are 1, so we're going to multiply 1 times all of the heights of the rectangles, because the left Riemann sum would be over, and over. So 2 plus 2 and 1/9 plus 2 and 8/9. And so these add up to 5, 7. So the area using a left Riemann sum with 3 subintervals is 7. For a right Riemann sum, we're going to use the right 3, because we're going to go from the right endpoint over and down. And it's going to be an overestimate. The width is still the same. The heights, though, are 5, 2 and 8/9, and 2 and 1/9. So that's 5 plus 5 is 10. So comparing those two, that's what the difference is between those two. The average is not the exact value. Okay? So what I need you to do is to double check when you make your table. If you have 4 here, the biggest mistake people have is to take all 4 of these and put them up here. There's only going to be the same number of rectangles. Otherwise, it's pretty straightforward. Okay, let's go to this second one where I said make 5 subintervals. So we're going to go through the whole process in case you don't understand how to make the table. So 5 subintervals of a width 5 of the interval 5 means we're going to have all these spaces, and I think it helps to visualize it sometimes. So I need to get a table that starts at 0 and goes all the way to 5, because I'm going to have 5 rectangles. I'm going to have 6 table values. So 0 is easy, that's 5. 5 is easy, that's 0. 4, 25 minus 16 is 9, so that's 3. That one's nice. There's some that are not so nice. Number 3, let's plug in 3. 25 minus 9 is 16, so that's 4. And then these two, we're gonna just change them to radicals. So 25 minus 1, so radical 24, and 25 minus 4, which is radical 21. So it's starting at 5, it's decreasing all the way down to 0. So the nice thing about making a table, you don't have to draw any rectangles in. If you're doing a left Riemann sum, you take the width, which in this case again is 1, times 5 plus radical 24 plus radical 21 plus 4 plus 3. If you want to do it, you can look at those rectangles. If it helps you, by all means, make the visual. But at some point, you're probably not going to need it. So that's going to be an overestimate. Whatever that number ends up being, you can multiply that out yourself. And then if we switch to do the right Riemann sum, again, the only thing that changes would be to take the 5 on the right and use those. Same width. So radical 24 plus radical 21 plus 4 plus 3 plus 0. So this area is going to be bigger because we traded in a 0 for a 5. Or sorry, this area is going to be smaller. We traded 0 for a 5. Again, that's because our first rectangle was on the x-axis, and then we went over and down from there. Okay, so comparing those two, if they would have asked for a midpoint Riemann sum, then you would have needed to make a table with the midpoint. So your table would have had 0.5, 1.5, 2.5, 3.5, 4.5. Those would have been your places that you found y. That would be what would change here, would be you'd have to find those new values. Everything else stays the same.